Welcome. If you recall from the last video, we built a server program which is waiting on a server socket for a client to connect. So in the Linux lab as I speak, there is a process blocked on an accept call waiting for a client connection. Let's go ahead and build the client code that will connect to that server and then read and write some data. As always, this code is out on Canvas. You can download and build it and change around with it. Top of the file, we have a bunch of includes that you'll need. I have a const integer, which is the size of the buffer that we will read and write into. I have a character pointer of the server name. For the example we're using, that server name will be UW1 32006. That's where the server is waiting. Here's the port that the server is waiting on. Remember, a socket is defined by an IP address and a port, and so those two together define a unique port in the world of the internet to go ahead and connect to. Here's the data buff, a pointer to the data buff we're going to read and write into. And then I create an address info structure and then two pointers to address info structures. And we'll look at and see how we use those in a second. And then finally, here's the index into the file descriptor table where the socket is kept once the client connects to the server. Let's look at the code. First thing I do is I make sure that I pass in the name of the server that I want to connect to. Make sure that I have two arguments coming in. argc is 2, which means one argument is passed to the name of the program. The argument will be the name of the server. Then I set up the hint structure, which, if you'll recall, was an address info structure. And I set it up in a way that I pass to the get address info call. The get address info call returns or fills in the results of different internet addresses where the socket that's been described could be. Let's look in a little more detail. I first set the family in the hint structure to AF unspecified or unspec, which allows either IPv4 or IPv6 to be used. I then set the sock type to sock stream, which specifies TCP. There's a flags parameter that I can use in the hint structure. I set that to 0 because I don't use any optional arguments or options. And then finally, I allow any protocol. Then I make the system call get address info, passing in the server name and the server port, which uniquely defines the socket. And then I pass in this hints structure, which tells a little bit about the sockets. And then what gets returned is a pointer to a list of different address info structures that are filled in. It basically resolves the internet address given the port, the server name, and then the hint structure. So now what we must do is iterate through this results that are passed back and see if any of them are connectable. So I have another pointer to an address info type called RP. I set it equal to result, and then I iterate through a linked set of address infos looking for one that I connect to. First thing I do is I go ahead and create a socket from the information in that first address info that's passed back. A socket call has a domain, which is the family. It has the sock type, which is usually sock stream, and then it has the protocol. And so if this socket is created successfully, I'll get an index into my file descriptor table, and then I can use that to connect. If the socket is not created successfully, I just loop back around and I update to the next result. So you see this RP pointer goes to RP AI next. Let's assume that the socket's created successfully. I then go ahead and connect to that socket with information about the address that was passed back. So here's the connect. At this point, when the connect succeeds, what happens is the server accepts that connection and creates a socket which points back to the client, loops back around and waits and accepts again if it needs to, or can just exit. So in our case, the server is just accepting the socket. When we drop out of that loop, either RP is going to be null, in which case we didn't find the server socket, so we go ahead and exit, or RP won't be null, in which case here I just print out the actual socket that we find. Finally then, I go ahead and I free the result. If you'll recall, the thing we passed into a get address info was a pointer, and so that got filled in with some information that now needs to be freed. All right, so at this point in time, I have a socket, and I can read and write into that socket. So I'll create a new data buffer that I want to go ahead and write. I'll fill it up with Z's. I go ahead and I write to the server the data buffer buff size. So that's just writing that information over. If you recall, the server will read that information. I go ahead and print out the number of bytes written. And then, if you recall, the server is going to write back some information to the client. And so on the client side, I'm just going to go ahead and read from that socket into that data buff. I think there'll be 1,500 bytes read. And then finally, if you recall, the server put in a special character, I think R, into the 13th character of the data buff. So let's just go ahead and print that out. When I'm done, I go ahead and close the client socket. Great. So let's go ahead over to the Linux lab and let's build that code and let's run it. You'll recall that we have the server on 0W1 320.06. Oh, it looks like it ran. It went ahead and called get address info with the server name. It got back some information. It created a socket, client socket using file descriptor 3. It then connected to the server. It went ahead and wrote 1,500 bytes, read 1,500 bytes, and then the 13th byte is the capital R. Let's look at the server. You can see down here, the server was waiting on socket 3. It accepted a socket, which was actually file descriptor number 4. It read the 1,500 bytes, which had to have a Z in one of the bytes, byte 0, I believe. And then it wrote 1,500 bytes.